So after the Sundays, that if else and switch case, today we are going to discuss about the loops. In this week, today and tomorrow, we'll discuss about the loop. Okay, the loop means where a block of code executes multiple number of times. And in this case, I'll show you, in fact, three constructs in which using which you can create loops. First one is for, second one is while, and the third one is do while. Okay. So our today's discussion will be about the for loop. The structure for the for loop is first an initialization, then a condition, and then an updation occurs. And it again creates a block. Say this block is v1. Let me name this block of code as v1. Now what happens here? What happens, start first initialization, let me call it init. Okay, init is executed only once. This is the first step. So this will be first executed. Now after executing this, it will go to check the condition. The condition is checked. If it is true, then the block that is within the for loop's body, that is executed. Okay. Then after b1, or the block, the for loops block gets executed, finishes execution, it goes to updation. That means updation is executed. Whatever is written in updation, that is executed. Okay. Then after updation, condition is checked again. Okay. So the condition is checked again, and if it is true, b1 executes again, and so on. And so on. Right. So again b1 will execute, again it will go to updation, updation will be executed, then it will check condition again. Condition means it is always returning some boolean. If this condition returns true, then b1 will be executed again. So this is what is creating the corresponding loop. Okay, this executes only once. Now this loop, this condition, then b1, then updation, then condition again, this loop ends only when condition is false. When this condition will be false, only then it will go out of the for loop and the control will come here. Okay. Let me show this with an example. Suppose I'm writing say for int I is equal to 0. In the initialization phase, you can even declare a variable as well. Int I is equal to 0, I less than 5, I plus plus. And some of you is unmuted. If you have nothing to ask, mute yourself. And another thing is that just like the if and else blocks, if else blocks and the blocks that I have told previously, if the block consists of only a single statement, you can omit these braces. So now suppose in the main function this code has been written. What will happen? First, initialization will occur. That will occur only once. So I is equal to 0. The value of I becomes 0. Then this condition is checked. So this will create the corresponding loop. Now this condition is true because 0 is less than 5, that returns true. Then this block is executed, and in this block this I that is being printed, which is 0. Okay. Now after, so from here condition checking, it comes to block. After block it goes to updation again, and in the updation we have written I plus plus. So I is incremented to 1. Now this is a standalone statement, so you can write I plus plus or you can write plus plus I. As I have mentioned previously, as a standalone statement, pre-increment and post-increment, they behave similarly. So I becomes 1. This condition is checked again. 1 is less than 5, and 1 is printed here. Right? This block is executed because this is true again. Then after this block gets executed, the controller will go to the updation part again. So I will become 2. It is again incrementing. I will 2. Then this condition is checked again. 2 is less than 5 because that is true. So as it is true, it will enter the block again. So 2 will be printed. Then after printing, it will go to the updation again. So I will become 3. It will come back to the condition checking again. Condition is still true, so 3 will be printed. From here it will go to updation again. I will become 4, and similarly 4 will be printed because at the condition it will be true again. After printing this for I is equal to 4, I will become 5. Now this condition is now false because 5 is not less than 5. If I would have given less than is equal to 5, then it would obviously it would work for I is equal to 5 as well. But I less than 5. So as soon as I becomes 5, this becomes false, and it will go out of the for loop here whenever I becomes 5. Okay. So that's how the loop, the basic loop works. Any of you have any query at this moment? Okay. Now let me show an example. Okay. This example will be a bit complex, but from this complex example, maybe it will not be complex for many of you, or maybe in fact all of you, but I'm jumping from this example to a bit next example will be a bit long jump, that is primality testing. And from this you will get to know about another idea of loop, another construct that is called break. I'll use that. Why that is used, you'll understand from this code. First of all, can any of you tell me what is the basic idea of checking primality of a number? Say input number is n. How will you determine whether n is prime or not?
Not divisible by 1 or itself, else except 1 or itself.
Yes, the number will be divisible by only 1 and the number itself. But how will you test it? Suppose I give you any number, say 17. We know it's a prime, but how will you check that it is a prime? What method would you follow?
We will check for every number less than 7.
Okay, so the most basic idea is dividing, checking divisibility from 1 to n minus 1, right? Sorry, 1 will divide this, so 2 to n minus 1, because 1 can divide any number. So I'll check the divisibility from 2 to n minus 1. That means if I have the number say 7, I'll check whether 2, 3, 4, 5 or 6 divides it. If none of them divides it, then 7 is a prime, right? Whereas if I take say 9, 2 does not divide it, but 3 divides it. So dividing up to 2 and 3 is sufficient. We do not need to check up to 8, right? So in the case of prime, no number from 2 to n minus 1 will divide that, whereas in the case of composite, any one number within 2 and n minus 1 will divide n. Is that clear? Is it clear to all of you till now? Now the fact
Yes.
is we do not need to check the divisibility up to n minus 1. Let me write a concept. I will not go to the proof, go to the mathematical proof in fact. So let me write it as this. Any composite number n will have a factor less than is equal to square root of n. If a number is composite, right, one of its factors should be within less than is equal to root of n. That will always happen. As for the case of 9, you can see that 3 is one of the factors, and 3 is less than square root of n. Right? In fact, 3 itself is square root of n. So less than is equal to square root of n. You take any number, say 90, say 93. Well, it's divisible by 3 again, which is less than square root of 93. It's a theory. You take any number, if that is a composite, you'll always find a factor within square root of n. Okay, so I'll change this a bit. It is sufficient to check divisibility from 2 to square root of n. Okay, we do not need to go up to n minus 1. As for example, in the case of 9, we do not need to go up to 8. It is sufficient to check up to 3 only. Now, what advantage it gives us? Obviously, it reduces time of execution. Rather than dividing all the numbers up to 8, it is sufficient to divide now all the way only up to 3, not beyond that. Or maybe if you have the number as say 99, it is sufficient to check only up to square root of 99. That's 10. In fact, I'm taking the upper bound, because 99 itself is not square number. So I'm taking the ceiling of square root of 99, which in fact is 10. Right? That means ceiling of means you do the square root, whatever number you have, take the just next integer. Okay, that will obviously give you 10, because 99 lies between 9 square and 10 square. So it is sufficient to check the divisibility from 2 to square root of 1. Right? In fact, it is sufficient to check up to 9 as well in this case. but I'm not going into that level of details. Any query till now? Okay. So if you want to check the divisibility whether 99 is primos composite, it's sufficient to check up to 9, and you can see that 3 itself is dividing 99. So we are done. Take any composite number, you will find this property. So if no number from 2 to square root of n divide n is prime, and if we find at least one number that will divide n within 2 to square root of n, n is composite. But what we're going to mention here is that for the case of 99, suppose we can check that it is sufficient to divide only up to 10, and you do not need to go all the way up to 98, that means n minus 1. So this reduces the number of division operations a lot, and hence speeding up your application, speeding up your program, because your program is now going to do lesser number of operations. Now, so let me now go to the program. One thing I think that, so I have to check from 2 to square root of n. So I is equal to 2, that is initialization. I starts from 2. I less than is equal to some method in C available, that is called, say, sqrt, that will give you the square root of this number n. I plus plus, check divisibility, observe how to think logic step by step. Check divisibility of n by I. Okay, this is our target. Is it clear till now? Any query at this moment? If any of you have any query at this moment, you can ask me. Okay, I will demonstrate it again. But it's important that you understand this step by step, how to think a logic step by step. That's extremely important. None of you have any question? Okay. Now, next phase. See, now listen to this very carefully. I'm telling you that, firstly, let me tell you, multiplication is faster than square root of n. Okay, doing multiplication is faster than square root, because in the square because determination of square root involves a pretty complex equation that you will know in those who are in CS or IT in the next, I think in the fourth semester, you will see scientific computing. You will see. Okay, multiplication is way faster than determining square root, and I'm claiming that these two statements are going to do the same thing. Int I is equal to 2, I less than is equal to square root of n, I plus plus, this block or this block. Int I is equal to 2, I into I less than is equal to n, I plus plus. These two blocks are going to perform the same task. In fact, this is going to cover the same range. Let me show you why. Suppose the corresponding block you are executing is B, and suppose the value of n is say 17. So square root of 17, I'm going to take the lower bound, it's 4. Okay, so I is equal to 2, 2 is less than 4, so it is satisfied. B will be executed, so B will be executed for 2. Then I plus plus 2 becomes 3, 3 is still less than 4, so it will be executed for 3. Then 4 as well. 4 is in fact 4 is square root of 17, right, when it is in integer form, so it will be executed for 4. So this block B is going to be executed for 2, 3, 4 on this line, right? Now let's see this line. I starts from 2, value of n is 17. 2 into 2 less than is 2 into 2, that means 4, that is less than 17, that is true, so B is executed. Then I plus plus, this condition is true for I is equal to 2, right? Then I plus plus, I becomes 3, it comes here, 3 into 3, that is still less than 17, right? So this condition is still satisfied, so it gets executed for 3, so B gets executed for 3. Then updation, after executing B, updation again, 3 becomes 4, 4 into 4, 16, that is still less than 17, so that will be executed again. Then I becomes 5, 5 into 5, 25, and it is now false, so it will go out of the for loop. So this will also execute the block B for 2, 3, 4. In fact, I have shown this example for n is equal to 17. You can check it out for any number, and I think many of you have already understood the internal mathematical trick what this line is doing. Rather than determining square root, it is only doing the square of I and checking less than is equal to n. Both of them are doing the same job. Is it clear to all of you till now? Are you with me till now? Or any of you have lost the path of logic? Okay. So for int I is equal to 2, I into I less than is equal to n, I plus plus. Though there is a much better way than even doing this, that is storing the square root variable in some variable previously and then comparing I less than is equal to that variable. That's also a good way. That I'll show you in the program. That is a trivial modification. Now, so now this, what I'm going to do in this block is that I'm going to check the divisibility of n by I. If n% I equals 0, that means what? That means n is divisible by I, and that means simply n is composite. So printf composite. Because n is divisible by one of the number, so it is composite, it's not prime. Any of you have any query till now? I'll ask this after every step to ensure that all of you are with the logic till now. Okay. Now, okay. Now, once we have this, now there's one fact that you need to observe. Suppose I am testing for say 16. N is equal to 16. So I is going to range from 2, 3, and 4. Now 16% 2 will be 0 because 16 is divisible by 2. So if you divide by 2, the remainder will be 0. So this condition is true. So composite will be printed. Then I will be incremented. I will become 3. It is not divisible by 3. So this block will not be executed because 16% 3 is what? 1, not 0. What is it? There is a remainder of dividing 16 by 3. Then I will become 4 and it will be divisible again. So it will print composite. But observe one thing is that the problem with this code is it is still executing even after we know the number is composite. Now, once we know that n is composite already, there is no point of executing it further, right? We have already got the result. Any other further division or any more operation will simply increase the execution time without any fruitful result, right? Because we already have the result. This the number is composite. So what to do here? Even though the problem here is that the loop will continue, even though we have computed it as composite, have found it as a composite, it will continue as long as this condition does not become false. So we have to break out of the loop as soon as we get the result. Because there is no point of continuing the division further. Okay? And how can I do that? There is a keyword that is called break. The break keyword, whenever a loop faces the break keyword, in fact, you have seen this break keyword during the switch case as well, right? That breaks out of the switch case on Sunday. You have seen that. This break also does the same thing for loop as well. If you use the break statement here, it will break out of the loop. Okay. So what am I doing here is that now what it is doing, these two lines together, now as soon as it is found composite, breaks out of the loop. Okay. Now, now let me demonstrate what is happening here step by step. Suppose I am taking this number 16 again. Okay. I is equal to 2. 2 into 2 is less than 16. So this condition is true. So it will enter this block. 16% 2 is 0. That means it is divisible. Composite will be printed and break. It will come out of the for loop immediately. So the composite will be printed only once. The divisibility 3 and 4 will not be done. Is it clear to you? Is it clear to all of you till now? That means, let me elaborate the functionality of break in more details. Break helps you to break out of the loop without completing the loop condition. That means break breaks out of the loop uh, even when condition, irrespective of the condition, irrespective of the loop condition. In fact, when break breaks out of the loop, the condition is still true. That generally happens. In fact, that always happens. Not generally happens, that always happens. Because if condition would have been false before that, it would have it would have already out of the for loop. It would have not even entered that break statement. So when it is facing the break statement, that means the condition is still true. Maybe in the next, maybe after the next updation, condition will be false. But at the moment the break is executing, the condition is still true. Right? So when, this is a very important point, remember, when break executes, the condition is still true. Okay, in fact, the loop condition. Okay, now let me show an example of break. And another thing is that as soon as it faces break, it comes out of the loop immediately. Anything within the block of that loop, within that loop body, that will not be executed after the break statement. Let me show this with a demonstration. Suppose I'm writing here printf before %d I, if I equals 3, suppose I'm writing a break, and then suppose I'm writing printf after %i. Now let me show you what will happen step by step. When I is equal to 0, this condition is true. So before 0, I am writing a short form of before as b and after as a. Before 0, I is equal to 3, this condition is false, so break will not be executed. So after 0 will be executed successfully. Now once this block is completed, it will go to the updation, which in fact makes I to 1. Because I to 0, then now I becomes 1. This condition is still true, so before 1, break still does not get executed because this condition is false. So after 1, then I becomes 2. Similarly, before 2 and after 2 gets printed, now I becomes 3. Okay, so this condition is true. So any block gets executed sequentially, right? Before 3 will be printed. Now this condition is true, so it will break. As soon as it faces break, it directly jumps here without looking into anything else. So after 3 will not be printed. So this is what will be your output after executing this. Let me show this. Because I'm writing printing before. Okay. It's loop.c and zero. As you can see, before 0, before after 0, before 1, after 1, before 2, after 2 got printed. Now before 3 got printed, but as soon as it faces 3, it breaks immediately out of the loop, and after 3 does not get printed. Is this concept clear to all of you till now? Any query at this moment? Okay. So that is what break does. So this is also happening here as well. Whenever we are finding that we have already found the number I, that is dividing n, we are printing out composite. And remember, break does not affect the if else block or something like that. Break always looks for the nearest loop or switch case. Break looks for nearest loops or switch case. This is bolo.
If I use break between any other syntax, then
Like
sir, without any loop. Generally, I'm writing something and I write a break and then some other
okay,
content.
that will give you a compilation error. Let me
Okay,
show
sir.
that. Suppose without any loop or switch case, I'm writing if let me have a variable int a is equal to 5. If a is equal to 5, break. And let me compile this. Not even execute this. Let me compile this. See, break statement not within loop or switch. Okay. So this will not work outside of loop or switch. This will immediately give you error. Okay. Now, so break breaks out just previous loop or switch. It will affect nothing else. Okay. So even though I have written the break within the if block, it is not if block it is affecting. It is affecting this for loop. So it will go out of the for loop directly here. As soon as I find some I that is dividing n, I'm obviously I found that it is composite. I'm breaking out immediately after the out of the loop. No further division is going to take place. Okay. Now, before further moving on, let me show you another fact. This is important concept. Any variable declared within a block. In fact, I'll discuss about this in much details when I'll discuss about function. Within a block has scope only within that block. It is called scope of a variable. And I'll discuss about this when I discuss about function. But what does it mean? Suppose I'm trying to access printf, say, after loop %d. I want to access this variable I from here. This variable I from here. It will immediately give you error because I will be shown as undeclared because this I has been declared as part of this for loop. So this I will be available within this block. So this will be available only within this block, starting from the for loop to the last of the for loop. Outside of the loop, I is not available. To make that I available, we have to just provide int I outside. Now observe, its block is now the complete function. Right? It's the block of I is now the complete function. So it will be accessible from anywhere within the function, within for loop, and even it will be accessible here I as well. I will be accessible here as well because now it is within the function block. Okay, and this I am accessing also from within the function, main function. So it is accessible there. Now the question is, what value of I will be printed here? The value that will be printed here is the value with which it has exited from the loop. First of all, let me remove this break statement from here and let me keep it simple for the first. For I is equal to 0 all the way 2, 3, 4, then when I becomes 5, this condition is false and it goes out of the for loop. So with what value I came out of the for loop? What is the value of I when I came? What is the value of I when it came out of the for loop? Yes, 5. Because when I became 5, this condition became false and it came out of the for loop. Right? Okay. So the value of I is 5 here. Okay, let me show that. So after this, after all these things, at the last statement you'll see after loop 5. All the way from 0, 1, 2, 3, 4, it remained within the for loop. Then I incremented to 5. This condition became false. It came out of the for loop. And the value of I remained 5 because with that value, it came out of the for loop. So after loop 5. Is it clear to all of you? So the value with which a variable, the condition breaks out of the loop, the variable stays with that value after the loop as well. Is it clear? Do you have any query here? Any of you have any query here? Anyone? Okay. So let me continue. Let me modify this program a bit more. Let me write this here and I'll make this int I out of the loop. So int I, then for I is equal to 2, I into I less than is equal to n I plus plus if n% I is equal to 0, then printf composite and break. So it is going to appear here with certain value of I, with that value of I with which it came out of the loop. Right. So the I has certain value here. But what value? Let me show that. Let me make a discussion here. First, if I is composite, first of all, okay, first of all, if I is prime, if I is prime, that means none of I has divided, follow the logic step by step, none of I has divided n, okay, from all the way from 2 to square root of n, none of the I has divided n. So this condition was never true for any I. Okay, this condition was never true. So this break never gets executed. So break never executes when I is prime, and it comes out of the for loop it comes out of the for loop. When it comes out of the for loop, when this condition becomes false, I starts from 2, checks the division, then I becomes 3, checks the division, I becomes 4, so on and on. None of them divides n, so break never gets executed. So this break never gets executed. So this, it comes out of the control, comes out of the for loop due to the normal execution or normal violation of this condition. So it comes out of the for loop uh, due to violation of I into I less than is equal to n, because this condition gets violated. That's why it came out of the for loop, right? So after for loop, this condition is already violated. This condition does not hold anymore. So I is present, this variable I is present with such a value that I into I less than is equal to n does not hold true anymore. So after for loop, I into I is greater than n. This is what holds true if I, sorry, this is if n is prime. If n is prime, is the logic clear to all of you? Yeah. Okay. But if n is composite, if n is composite, what will happen? That means sum of the I divided n. So it came out of for loop. It came out of for loop due to break. Right? Because sum of the I divided n, that's why it printed composite and executed break, it came here. So this condition still holds true. Maybe at the, maybe for the next value of phi this would become false, but at least for the current value of phi, the value of phi with which it broke out of the for loop, this condition still holds true. So I into I is less than is equal to n still holds true after after for loop. Is the logic clear? So if n is prime, after the for loop, here at the end of the for loop, if n is prime, I into I is greater than n holds true, and if n is composite, I into I less than is equal to n holds true. Okay, so we are printing for the composite here already. Let me print for I into I is greater than n, printf prime. This will do the job. Let me execute, let me implement this, show that. Suppose let me take the n from user itself. Okay. This is what we have implemented here from our logic, and this works perfectly. Compile this, and then I am going to execute it out several times. Suppose 301. This is composite. Now you may ask for which number it got composite. That means what is one of the numbers that divided the number. So you can write composite for say percent %b I. So the first I that divided n, you will find it here. So 301 is composite for 7. That means 7 divides 301. What about 311? It's prime. 311 is prime. But maybe 6437. 41 divides 6437. Name any number. It will give you. Let me take some small number which it is known as prime. So prime. Okay. Is it clear to all of you? This logic? Is this logic clear to all of you? Any of you have any query till now? Okay.
No, sir.
Okay. Now, here we have seen about break. Now, let me tell you about continue. This is another statement. First of all, I'll show the functionality of continue by showing its difference with its behavior, showing its difference with break in terms of its behavior. Suppose I'm writing int I is equal to 0, I less than 5, I plus plus. Suppose I'm doing a printf of after %d I, and suppose I'm writing if I is equal to 3, break, and then I'm writing printf b %d slash I, and for this case we have seen that the output will be something like this: a0, b0, a1, b1, because for 0 1 it got executed successfully. A2, B2, and then A3. The value of I is now 3. A3 gets printed. But this condition is true. It breaks out of the loop. It comes here. This statement does not get executed further. Now, let me change this break statement into a continue statement. First of all, what continue does? Break takes the control out of the for loop. Continue takes the control to the updation part of the for loop. Now, this is the difference, but this difference makes a huge impact in the behavior. Let me show how. As expected, for 0 1 2 the behavior is same, because for I is equal to 0 1 or 2 this statement is not anyway being executed. So A0 B0, A1 B1, A2 B2, and A3 will be executed as well, because when I is 3 this line will be executed at first. Now continue is fetched. Break took it out of the loop. What continue will do is that it will take this here. So B3 will not be executed, rather I will become 4 and this loop will continue. So A3, then A4. Now when I is 4, this condition is false again, so continue will not be executed. So so B4, then I becomes 5 and this condition is false. Now it comes out of the loop because this condition is now false. So that's the difference between break and continue. Break takes you out of the loop, continue takes you to the updation part of the loop. For both of them, whatever is within the loop, once any one of the break or continue gets executed, whatever is left within the rest part of the loop body will not be executed. But the and one last thing that I need to mention, because it is already 2:55, I guess you have the class as well after this. If I remove this line, right, continue has no effect, because doesn't matter, because continue take you to this updation statement anyway. So continue as the last line of the loop has no effect. Never use continue as last line of the loop. I will show you the execution of continue tomorrow. Okay, continue as last line. Okay, I'll discuss this tomorrow as well, because it is already 2:59 and we have class, I think. I'll keep my discussion up to this today. We'll see you tomorrow at 2 to 3. Okay.
Thank you, sir.
Welcome.
Thank you, sir.
Stopping the sharing and stopping the recording.